So let us start. So we'll solve some of the problems which were given in the previous years. Got it? Okay. So previous year problems on vector calculus. Now in that actually in 2016 there is a problem. Prove that the vectors A is equal to 3i plus j minus 2k, 3i plus j minus 3k, and b is equal to minus I plus 3j plus 4k, c equal to 4i minus 2j minus ck, minus 2j minus 6k can form the sides of a triangle. Can form the sides of a triangle and find the lengths of the medians of the triangle. Medians of the triangle. So this was given in 2016. Okay. So how do we solve this? Any idea? Any idea how we can solve this? Anybody? So this is actually straightforward on vectors. It's not even on the vector calculus. So these are from the basics of vectors. Here actually, without mentioning, if he simply gives the position, then this is nothing but the position vectors. So A comma B comma C are the position vectors. So if these are the position vectors, which are nothing but starting from an origin, and then let us say this is point A, and this is point B, and this is point C. Then from this origin, O vector, right? So from O actually, this is one vector called A vector, and then this is the B vector, and this is the C vector. So these are the three different vectors that are listed by the problem statement, right? And here actually for finding out the distance, right, you have to identify the vector first. So distance, we mean the modulus of that vector. Now here, if you want to find out the vector AB, so AB vector actually if you want to find out, AB is equal to, so B minus A. This is the AB vector, right? So this AB vector, you can find out B minus A. So this value is going to be, that is minus I plus 3j plus 4k minus 3I minus j plus 3k. So this is minus I minus 3 minus 4I plus 3k minus j plus 3j. So 3j minus j. So this is going to be plus 2j, and then 4k plus 3k plus 7k. So this is the vector AB. Now in the similar manner, vector BC you can find out, that is C minus B. So this is the BC vector. So this is BC vector is going to be vector C, that is 4i minus 2j minus 6k, and then minus b vector, that is plus I minus 3j minus 4k. So this is going to be 5I minus 2 minus 3 minus 5j minus 6 minus k minus 10k. So this is the BC vector. Then, so we have got AB vector and BC vector. Then, so the CA vector, if you find out, CA is equal to, so A minus C. So A minus C, if you find it, this is vector A, that is 3I plus j minus 3k minus A vector, so minus C vector, that is 4I plus 2j plus 6k. So this is going to be minus I plus j plus 2 plus 3j minus 3 plus 6 plus 3k. Got it? Yeah. So now actually if you add these two vectors AB plus BC, AB plus BC, so if you add these two vectors, then the resultant what we are going to get it is, that is AB plus BC minus 4 plus 5, that is plus I plus 2 minus 5, that is minus 3 plus 7 minus 10, that is minus 3k. If you notice this, this is minus of minus I plus 3j minus plus 3k. So this is going to be minus of CA vector. Got it? So or actually AB plus BC plus CA, so this sum is coming out to be 0. Hence the three vectors will form a triangle. Got it? Understood or not? So AB vector, BC vector and CA vector. So AB plus BC plus CA is coming out to be 0. Then we say that that is forming a triangle. This is as per the triangular law of vector addition. Got it? Understood, Deepak? Now actually how to find out the median? How to find out the medians? So medians are nothing but the midpoint of these sides. Now actually let us say the midpoints are, so this is P and this is Q and this is R. Now if you want to find out the midpoints, then actually this will be A plus B by 2 is the P vector. So this is the midpoint vector. Got it? So note down till this point. I am going to erase it. Right? So they can be collinear. No, this can't be collinear. Why? Because as long as this triangular law of vector addition is getting satisfied, then obviously this can't be collinear, right? Got it or not? If the magnitudes are same, so what you are thinking is, so this is A plus B plus C. If all are under collinear, obviously the sum of these two vectors, it won't be the resultant, right? No, so till this point it is sufficient. As per the triangular law of vector addition, so the sum of all the three sides of the triangle, if they form the vectors, then it is going to be 0. Got it? Then the next part is, once you find out these vectors, so you have to identify. I'll just write it here. AB equal to minus 4I, or actually so we'll derive that. So what you are saying is, suppose if this is one vector and this is one more vector, and then the resultant is this vector, right? Okay. So actually, so even this also true, collinear also, but actually it forms a triangle of area 0. But actually what he is trying to say here it is, so in this particular problem statement, if you can think of, suppose if this is how actually the vectors are, then actually it won't form the triangle, right? Got it or not? Now actually this kind of the case actually what we have proved now. Now in this case it won't form the triangle. Now actually we have verified that this is not going to be the case. Then we proved that this is going to be the case. And even this case also, this is also a kind of triangle with 0 area, collinear vectors. Got it? Maybe that way you can interpret this. Understood or not? So these triangles, so collinear we mean, see, take this one and take this one, and this is one triangle. Now actually if you tilt further down like this, then actually this is going to be one more triangle. Now actually if you make further down, so this is going to be one more triangle with 0 area. So that is how actually you can interpret. But actually the triangular law of vector addition is still satisfied here. Got it, Deepak? So as long as actually it forms the, so it satisfies the triangular law of vector addition, that is AB plus BC plus CA is equal to 0, then actually we say it is a triangle. Got it? So, but a triangle with 0 area also can be possible. I think we don't need to do that, I think. So what you are saying is actually, yeah, so AB plus BC. Okay, yeah. So maybe actually as a value addition, maybe actually you can prove that also. But actually I think I don't need to do that. So AB plus BC, what you are trying to say is AB plus BC, this is equal to CA, right? So if this is the case, actually this is satisfies the triangular law of vector addition or minus CA, right? And along with that actually, so you may have to verify, yeah. So maybe you can verify this. The sum of these two, if it is equal to this one, then actually it is the sides of the same line. So that means the sum is coming out to be the same, means with 0 area triangle. So maybe actually you can avoid that case in case if you wanted to specifically prove that. Yeah. Anyway, so maybe actually you can conclude that actually, so we can prove this as well. That is, taking the side lengths are same. Sum of the triangles actually is, sum of the side lengths are coming out to be the sum of the, sorry, the third side. So this is A and this is B. Then A plus B vector, if it is equal to C, then actually, so this is a triangle of side of area 0. So this actually you can avoid it by proving that. So from the conditions actually you can prove that as well, right? So we have got the vectors in numerical values only. So from there actually you can find out these values. Got it? And the second part of the problem statement is, what he has given is, he asked us to find out the medians. Medians actually in this particular triangle, this point is P and this point is Q and this point is R. Now from here actually this is the vector A and this is vector B and this is vector C. Now the median is nothing but, so A plus B by 2, this is the vector OP. So this is the OP vector or the P vector. Similarly, you can calculate, this is the C vector. So you can calculate Q is nothing but B plus C by 2 and R is nothing but A plus C by 2. Now actually this is how actually you will get 3 more position vectors which will represent the midpoints. Yeah, Deepak. So that can also be done. So that is also a correct approach also. So that is actually AB, BC, CA. When you want to find out that, so you don't need to further extend, right? So anyway, actually, if you are able to find out the vector AB, BC, CA, and then, so finding out the modulus and then verifying the sum of these two is greater than the third side. So that way also you can verify whether it is forming a triangle or not. Now actually, rather than finding out the modulus values, if you are able to find out the vector sum itself, actually you will be able to conclude, right? So that's why actually either of the approach you can take it. Got it, Deepak? Okay. So here actually, so this is the medians, actual median vectors, actually we have got it. Now actually median vector, suppose if you want to find out this median, so this is, you have to identify a vector from P2, so this vector C, so that is PC vector you can find out. So P value we have got it, so this is the P vector. Similarly, you can find out this vector, that is, this is OQ, so that is the Q vector, actually we have got it. Then if you want to find out this median, then AQ vector also you have to find out, and then this median if you want to find out, then BR vector you have to find out. Now the modulus of these values are nothing but the length of the medians. Got it? Any questions? Okay. So this is actually straightforward. So this is actually a little lower standard question only. Note down one more. A vector field given by, this was given in 2015, a vector field is given by f equal to x square into x square plus xy square into I plus y square plus x square y into j. Verify that the field F is irrotational or not. Verify that the field is irrotational or not. Find the scalar potential. Find the scalar potential. Now actually this is straightforward question. There is no confusion in this. So he asked us to find out del cross F value. So del cross F value, this is I, J, K, and this component dou by dou x, dou by dou y, and dou by dou z. And for this x square plus xy square, and then y square plus x square y, and 0. So for this determinant, this value is going to be I into 0 minus dou by dou z of this is going to be 0 minus j times of, so 0 minus 0 plus k times of, so this is dou by dou x of, so this is 2xy minus dou by dou y of 2xy. Yeah. So this is going to be 0. So here actually del cross F is coming out to be 0. Hence the flow is irrotational. We also call this as the field is conservative field. Conservative field. Now if it is a conservative field, then F can be expressed as del phi. Ideally it is minus del phi, but you can treat as del phi. So that minus sign is introduced just because of the reason that the potential value or the flow actually always passes from higher potential to the lower potential. Now if you take this as the positive direction of the velocity, then here higher value of phi will be there and here lower value of the phi will be there. Hence the difference is coming out to be a positive value, but the flow is in the opposite direction. Got it? So higher to lower. If you take this minus this, then it is going to be a negative value, but the flow is towards the negative direction. That's the reason actually when we usually treat this as minus, but actually for mathematical purpose, so you don't need to consider this. Got it? Yeah. So here actually del phi. Now del phi value is nothing but f vector x square plus xy square into I plus y square plus x square y into j. This value is equal to I dou phi by dou x plus j dou phi by dou y. So you don't need to consider the k factor because there is no k value in this. So it implies dou phi by dou x value is equal to x square plus xy square, and then dou phi by dou y value is y square plus x square y. So it implies if you integrate it, phi is equal to integral x square plus xy square dou x. So this is going to be x cube by 3 plus x square y square by 2 plus some random function of y. Similarly, here also if you take the phi value, this is y square plus x square y into dou y. This is y cube by 3 plus x square y square by 2 plus f or g of x. Now here actually if you try to equate these two values, g of x value is this one and f of y value is this one. So in total the phi value is x cube by 3 plus y cube by 3 plus x square y square by 2. So this is the potential. Here I told you, right? So this is ideally this has to be a minus value, but we always treat this as the phi value, incorporating the minus value into the phi. So that's why actually for mathematical analysis purpose actually we take this del phi, but ideally it has to be a negative value. Got it, Deepak? The reason also I have given. So the flow actually always happens from the higher potential to the lower potential, but the difference of the potential, if you take it, it will be a negative value. So in the exam actually, so I think so you can mention that point and then proceed either way, or else actually if you want to treat this as minus, that can also be done, but for this actually you are going to get a negative value for this. Got it? You can mention that explicitly. So any questions on this? Evaluate by Stokes theorem. Evaluate by Stokes theorem. Integral y dx plus z dy plus x dz. Over the contour C, where C is the curve given by given by x square plus y square plus z square minus 2ax minus 2ay equal to 0, comma x plus y is equal to 2a, starting from 2a comma 0 comma 0, comma 0 comma 0, and then going below the z axis, and then going below the z plane. So can you try to solve this problem? This should be the straightforward problem. You solve it on your own. Anybody got the answer for this? Okay, let me solve this. See this, x square plus y square plus z square minus 2ax minus 2ay is equal to 0. Then this equation can be further simplified as x square plus y square x minus a whole square plus y minus a whole square plus z square is equal to 2a square. Can I do this? So these two together will form x minus a whole square minus a square. So that goes to the other side. So minus 2 pi a square. Let me check that. I think so there is some root 2 is not matching. Okay, let me check that. Okay, so x minus a whole square plus y minus a whole square plus z square is equal to 2a square, or this I can write as root 2a whole square. That means this is a sphere of radius root 2a. Now here let us say this is x-axis and this is y-axis and this is z-axis. Now the center lies at this point where this length is a and this length is a. So this is the center, and then so this sphere is having a radius of equal to root 2a. Now if this is root 2a, then actually if this is the center, this length is root 2a. That means this will pass through like this. Got it or not? So this is a spherical shape. So this is on the z plane. So on the z plane actually, so z plane lies this way. Yeah, this way. Got it? And then, so this is intersecting at this particular point and this is intersecting at this particular point. Now, if you draw a line like this, so this is the plane equation. So this plane equation is given by x plus y is equal to 2a. So this is the plane equation. So this is the plane equation, right? Now actually the spherical equation we have got and the plane equation also we have got. And then, understood or not, how I have drawn? Is this understood diagram? Now actually, so you can identify the value of f. F is nothing but yi plus zj plus xk. And del cross f value, you can find out. So del cross f is nothing but ijk, dou by dou x, dou by dou y, and dou by dou z. And this is on y, z, and x. So this value is I times of 0 minus 1 minus j times of 0 minus 1 plus k times of 0 minus 1. So this is 1 minus 0. So this is going to be minus I minus j minus k. So this is the del cross F value, right? So once you get the del cross F value, minus I minus j minus k, then you can apply Stokes theorem to find out the surface integral. So to find out the line integral, you can use the surface integral value. So this curve is x plus a is equal to 2a. Now, so the normal vector to this particular surface, right? So this particular surface normal vector goes this way. That normal you can find out n cap is equal to, so del phi by mod del phi. So this is del phi operated on x plus y. So I dou by dou x, that is I plus j dou by dou y plus j divided by square root of 1 plus 1. So this is I by root 2 plus j by root 2 is the unit normal vector. I hope you understood. So find out del phi divided by mod del phi. Del phi is dou by dou x operated on this I times, and dou by dou y operated on this again, and dou by dou z anyway 0. So this is the unit normal vector. Now this is going to be, so double integral over the surface S, surface given by this particular shape. So this is a circular shape for us. Now del cross F dot n cap ds. Now del cross F is, this is minus double integral over the surface S I plus j plus k. So this minus taken out, dot n cap is I plus j by root 2 into ds. So 1 by root 2 you can take it out, minus 1 by root 2, and then I dot I is 1 and j dot j is 1. So this will come as 2 and then ds. So this is minus root 2. So this is minus root 2 integral over the surface ds given by the surface. Now this surface actually, so this is on the circle, x plus y is equal to 2a. Now this starts with x is equal to a and ends with x y is equal to 2a. So this length is 2a and this length is 2a. Now this particular surface area we want that. So what is that surface area? This will be a circle, right? So circle of radius root 2a. So root 2a circle area we have to be identified. So this is minus root 2 times of pi s pi r square, where r is root 2a. So this is minus 2 root 2 pi times of a square. Got it? Understood? Is this understood, or do you have any questions on this? So this is how actually you will be able to solve with the help of Stokes theorem. So there is one more simple problem, that is calculate del square r power n. So find del square r power n. This will be straightforward and simple. Can you find out? This is, I think, direct problem from BS Gravel. You want me to solve this? Okay, so let me solve this. See this, del square can be written as del dot del of r power n. So this is how actually you can write any del operator, which is nothing but the scalar operator del square, which is coming between two different vectors dot product. So this dot product is in between del dot del, and then operated on r power n. So this can be written as del dot, so del of r power n. So del of r power n is nothing but, so I'll just write it here. Del of r power n is equal to I dou by dou x plus j dou by dou y plus k dou by dou z operated on r power n. Now if you operate this, then this is going to be n into r power n minus 1 into dou r by dou x into I plus n into r power n minus 1 into dou r by dou y plus into j n into r power n minus 1 into dou r by dou z into k. But the standard relation of r is x square plus y square plus z square is equal to r square. So 2r dou r by dou x is equal to 2x, or dou r by dou x is equal to x by r. Similarly, dou r by dou y is equal to y by r, and similarly dou r by dou z is equal to z by r. Now if you replace it here, then this is going to be n into r power n minus 1, and then in the numerator xi plus yj plus zk divided by r, or in other words n into r power n minus 2 into r bar, right? So this is del of r power n value. Now actually you have to do a dot product for this. So del dot del of r power n. So this you can get it, that is, this is as if like del dot operated on n into r power n minus 2 into r bar. Now this is as if like del dot operated on a scalar getting multiplied by a vector. Now if you want to operate this way, this is going to be f dot del phi plus phi into del dot f. So this is the resultant if you do this operation, right? Now this value, if you operate it, this is going to be, so n is a normal value, you can put it out, and then so r power n minus 2 into del dot r bar plus r bar dot del operated on r power n minus 2. So this is going to be n into r power n minus 2 and del of r bar, so del dot r bar, so this is going to be 3. So del dot r bar is nothing but del dot r bar is equal to I dou by dou x plus j dou by dou y plus k dou by dou z operated on, so dot product with xi plus yj plus zk. So this is dou by dou x will be 1 plus 1 plus 1. This is going to be 3. So that's what is the 3 actually I have used it here. Then r bar dot, so del of r power n minus 2. Earlier actually when we operate on n, then this is coming out to be n into r power n minus 2 into r bar. Now instead of n, it is going to be now n minus 2. So this is n minus 2 into r power n minus 4 into r bar. So this is the value we have got. Got it? Note down till this point. I am going to erase it and rewrite it. Done? Okay. So once you got to this point, then actually this value is going to be now, so this is n is outside, then this is r power n minus 2 into 3 plus now n minus 2 into r power n minus 4 into r bar dot r bar. So r bar dot r bar is r square. Now this is n into 3 times of r power n minus 2 plus n minus 2 into r bar, so n minus 4 into r square, that is n minus 2. So this is n into r power n minus 2 into So 3 plus n minus 2. So this is going to be n plus 1. So n into n plus 1 into r power n minus 2. This is the value of del square r power n. Got it? Understood? So actually, so related to finding out the curvature and torsion, so there are actually other some shortcut formulae which you have to remember, because actually sometimes actually in the questions directly it will be asked. So those formulae I am going to give it. So actually, so if the position vector is given, so usually the position vector is the only information we are going to get it. Is given, then based on the value of the velocity vector, that is dr by dt and d square r by dt square and d square r by d cube r by dt cube. Now actually, so this is the velocity and this is the acceleration and this is derivative to the acceleration. Now finding out these values, right? So once you find out these values, this is the velocity vector v and this is the velocity acceleration vector a. So let I call this as the vector p. Now to find out the curvature, so k value is straight away given as v cross a divided by modulus of this divided by modulus of v bar cube. So this is the straightaway curvature equation. So with this magnitude, you are going to get the curvature value straight away. Similarly, the torsion value tau, you are going to get it as, so the modulus of, so this is the velocity vector dr by dt, or actually, so this is the v vector, a vector and p vector. Now for this actually, you have to identify the determinant of it. So this I call this as Vx, Vy, Vz, and similarly Ax, Ay, Aj, and this is Px, Py, Pz. Now this determinant value straight away will give the torsion magnitude. I think so. These are actually some of the important problems that we can discuss. Fine. Okay. So actually based on this formula, right? So there were two problems which were given. You can try it on your own. So this is just applying the formula and then getting it. Note down this. Find the curvature vector at any point of the curve. Find the curvature vector at any point of the curve. So R bar equal to T cos T into I plus T sin T into J. So find the curvature for this. Got it? So you can try this. So this is just find out the V value and A value, that is one derivative and the second derivative, and then calculate V bar cross A bar divided by V bar cube modulus of R. Exactly in the similar manner, there is one more problem, that is show that the curve x of t is equal to ti plus 1 minus t square by t j plus 1 minus t square by t k. So this actually he said that lies in a plane. So he asked us to prove that it lies in a plane. So if you ask us to find out if it lies in a plane, then which essentially means that the torsion has to be 0. So take the first derivative, second derivative and third derivative and take the determinant of it, and it has to come out to be 0. Got it? Okay. So any questions? Okay, so okay, fine. So if no other questions, I'm going to stop the class for today. So in tomorrow's class also we'll solve some of the previous year problems and then close this topic altogether. Fine.